Welcome to EDU World Space.
Question. We are told that hydrogen is an unusual element because it behaves in some ways like the alkali matter and in other ways like non-matter. Its properties can be explained in part by its electron configuration and by the value for its ionization energy and electron affinity. So we are to explain why the electron affinity of hydrogen is much closer to the values for the um, alkali element than for the halogens. So the reason is because hydrogen has a single electron orbiting a bar proton. So hydrogen looks like this. You have one proton and then you have one electron. Okay. So the electron is unpaired and the 1s orbital is incompletely fused. So you have electron configuration as this. So the electron is unpaired because it's sitting inside, right? And this is same as the alkali metals because when you look at the alkali metals, they have NS1. So this is alkali metal. NS1 configuration where N can go from 1 to 7. Okay. So the similar electron affinity to the alkali metal reflects the stability for a full s orbiter. And a second way to look at this is to look at the Z effective. Unlike the halogens, their effective nuclear charge is approximately zero. For hydrogen, corresponding to the set effect, can look at the set effective. So for the hydrogen atom, effective nuclear charge is approximately zero, and that is unlike for the halogen, corresponding to weak electron affinity. So the next question said that hydrogen, so B, all these are A. So B said that um, is the following statement true? Hydrogen has the smallest bonding atomic radius of any element that form chemical compound. So if um, if not, correct it. If it is, explain in terms of electron configuration. So hydrogen is 1s1, right? Is it the smallest? Maybe yes, maybe no. So we can prove this. So we have other species of hydrogen as H plus, and also we have H minus. So H plus is 1s0, and it will be smaller than um, uh, H neutral. Then we have H minus to be 1s2, and it's going to be bigger than the H neutral. So do we have any species or chemical bond where we have H plus? Yes, we have HCl, and that is hydrogen is positive and here is negative. So H plus is the smallest, not just the hydrogen neutral. Okay. The next question says that explain why the ionization energy of hydrogen is close in value is closer to the values for the halogens than for alkali. It's because when you look at hydrogen is 1s1, right? And the halogen is, for example, NP um, 5. Okay, so the energy that is required to remove this electron will be higher. This is, let me put this as halogen, and then alkali, you have NS1. So the energy that is required to remove the 1s electron here will be considerably higher because the 1s orbital is very close to the nucleus, and because uh, this hydrogen wants to form the duplet configuration. So all those put together will make the ionization energy for hydrogen to be high. So compared to the halogen they need one electron to form their octet outer shell configuration. So to remove one electron from this p orbiter will be high because of that. So when you look at alkali metal, they are very big, and that is why this is high, because relatively the halogen are smaller than alkali metal. So alkali metal are very big, so they have the electrons in the atom shell well shielded from the nuclear charge. So that makes it easier for the electrons here to be removed compared to in hydrogen. So that is why the ionization energy for um, halogen and hydrogen are they are closer to each other than to the alkali metal. And then the last one said that the hydride ion is H minus. We're to write how the process corresponding to the first ionization energy of hydride ion. So hydride ion has 1s2 configuration. So first ionization energy will be H plus to give, sorry, H minus will be H minus going to H plus H neutral. I'll just put it as neutral plus E minus. So that's the process. So the next question is saying that how does the process in part D corresponds to the process for electron affinity of neutral hydrogen atom? So electron affinity of neutral hydrogen atom will be plus E minus to give H minus. So they're just like a flip. So the high E will be for the H minus will be equals to the negative value of the EA for the hydrogen atom neutral.